All right, so the second part of this lecture is gonna be regarding geometric progressions. Now, when you're talking about geometric progressions or geometric sequences, there's basically a common ratio now between the consecutive terms. So instead of the common difference that we had in arithmetic progressions, we're now gonna have a common ratio. What does that mean is now we're going to either multiply or divide with something. Basically, if you're looking at this sequence, you can see that each term is being multiplied with 3 to give the next term, right? Hence, your common ratio, which is represented by R, is going to be 3. In the second case, you can see that you are multiplying each of the term with minus 0.5, or you're multiplying it with minus 1/2. So when you do that, you basically are saying that the common ratio is now going to be minus 0.5. So now R is basically minus 0.5, which is giving you the next term. Now, how can you find it? In the second sequence, it might be a bit hard. So what you can do is take the second term, divide with the first term. So R is going to be minus 1/2, which is minus 0.5. Let's try it with some other random term. So if we try it with, let's say, 0.5 and minus 1, so you're getting 0.5 divided by minus 1. That is again going to give you minus 0.5. So does not matter which two consecutive terms you're taking, the answer is going to remain the same. Just remember that put the second term in the numerator and the first term that you're using in the denominator. So that is basically a geometric sequence. Other than that, A remains the same. Now you have R instead of D, N remains the same, AN remains the same. If I look at the formula for the terms of the geometric progression, that is basically this. AN is equals to A R n minus 1. This n minus 1 is basically just applied on R. So this is your geometric term formula. Let's say we have to find it for this 2, 6, 18. So if I have to find the term formula for 2, 6, 18, I know my first term is 2. The ratio here is 3. In your differences, you were taking the addition subtraction sign along with the difference. In ratio, you're not going to take any multiplication or division sign. You're just going to see what you are multiplying it with, and it's going to be written over here. However, if there's an addition or subtraction, a plus or minus in the multiplication, then you're going to write that. Okay. So the geometric sequence for this is going to become AN is equals to A, which is 2, times R, which is 3, n minus 1. So AN is going to be equal to 2 times of 3 n minus 1, which is finally going to be your answer. You cannot multiply 2 and 3. Always remember these two cannot be multiplied until and unless you resolve the power to 1. Okay. So this is the geometric sequence for it. Let's say we have to find the term in 5. So what I'm going to do is A5 is equals to 2 times of 3, 5 minus 1. That is going to give me 2 times of 3 raised to the power of 4. That gives me 2 times of 3 raised to the power of 4 is 9 into 9, which is again 81. And 81 into 2 gives me 2 and 16, 162. So the fifth term of the sequence is 162. You can see that when you multiply 18 with 3 once and then multiply it again, you're going to basically get 162. This is basically how you're using your geometric sequence, and this is the formula you guys need to remember for it. All right. Now moving forward, let's look at an example. So the sixth term of a geometric sequence is 486. The 10th term is 39,366. Find the first term with the common difference. So finding A and finding D. Again, they're asking you to find two variables, hence we're going to make simultaneous equations. So the first equation says the sixth term is 486. So we're talking about A6, that is equal to A, or n minus 1 is 6 minus 1. So 486 is basically equal to A r raised to the power of 5. This is my first simultaneous equation. Now for the second one, I have the 10th term is 39,366. So A10 is basically equal to AR 10 minus 1. It's equal to 39,366, which is basically AR raised to the power of 9. This is my second simultaneous equation. When I solve them simultaneously, I'm going to get A as 2 and R as 3. So this is basically going to be your final answer. Now moving forward, again, you have to see what the sum of a geometric progression is. So the sum of the geometric progression is this formula. Just remember the first one, it's fine. You can do all the questions to it. You don't need to get into this formula. So this is the formula for it. Now, if this is a geometric sequence, how am I going to apply the formula? So S of Sn, I'm finding it for the first, let's say, 10 terms. So let's substitute it. So A is 1. 1 minus R is basically, in this case, you can see that it is 3 because we're multiplying with, 1 into 3, 3 to 3, 9. Yes, so it's basically 3. So 1 minus 3 raised to the power of n, which is 10, divided by 1 minus 3. So just sort it out. So you're going to get 1 minus 3 raised to the power of 10 divided by minus 2, and you can basically find the answer to it when you put it in your calculator. So this is the sum formula for your geometric progressions. You need to remember this to do different kinds of questions. Now, again, you don't need to get into the proof of it, so we're just going to leave this out. And this proof is also not included in your paper, in your exam, so you can leave this out as well. Now, moving on to the sum to infinity of a geometric series. Now, what is a sum to infinity? In the last one, in the arithmetic series, we just talked about the sum of the arithmetic sequence, but we did not talk about what the sum of infinity is. So sum of infinity is only applicable to geometric series. So we're going to look into the geometric series and what the sum of infinity is. So this is the simplest formula for the sum of infinity. The questions are going to be quite simple. It is going to give you the sum of infinity, ask you to find A or R, or just give you A and R and ask you to find the sum of infinity. So the sum of infinity formula is A divided by 1 minus R. So for example, if you have to find the sum of infinity of the same term, same sequence here, so 1, 3, 9, 27, 81. So what we're going to do is, we're finding it for 1, 3, 9, 27, and so on. So the sum of infinity for this term, this sequence is going to be A, that is 1, divided by 1 minus R, that's 1 minus 3. So you're going to get 1 divided by minus 2, that's basically minus 0.5. That is basically the sum of infinity. It's a very simple one for this specific progression. However, it's very complicated in the way that it gives you a lot of decimals and some numbers like that. So basically, that is the sum to infinity. Now, let's look at an example here. The question says a geometric progression has the first term A. Each term is multiplied by 0.9 to get the next term. That means your R is 0.9. The sum of the first 5 term is this. That means your sum of the first 5 term is 409.51. Part A asks you to find the value of A. So what we're going to do is, we have been given the sum, so we're going to use the sum formula. So the sum of 5 terms is 5 divided by 2. 2 times of A, which is A, plus B. Sorry, it's a geometric progression. We're going to use the sum formula for the geometric progression. So that is Sn is equals to basically this one. Okay. So A 1 minus R raised to the power of n divided by 1 minus R. Sum of 5 terms is equals to A remains A, 1 minus R is basically given to you as 0.9. N is given to you as 5 because we have to talk about the 5 terms, minus 1.09. Sum of 5 terms is basically equal to 409.51 is equals to A into 1 minus 0.9 raised to the power of 5. This 5 is only applied to R, remember, not to 1. Divided by 1 minus 0.9. So you just take this on the other side, you apply basic algebra to it, and you're finally going to get the final answer of A as 3. So the first term for this sequence is 100. Now, part 2 says, what is the sum to infinity of the progression? Now, sum to infinity, we have the formula. That is A divided by 1 minus R. You found A in the last part, you're going to use that. So 100 minus 1 minus, 100 divided by 1 minus 0.9. Again, you're just going to get the answer to it, which is basically 1000. So this is the sum to infinity. This is basically all that is included in your geometric progressions. Let's just make a short summary, a quick summary of what we've done regarding this. So for your geometric progressions, these are the formulas that you need to remember. The first one is the term formula. So an is equals to a r n minus 1. Then you have a sum formula that is Sn is equals to a 1 minus r raised to the power of n divided by 1 minus r. And then you have the third formula that is sum to infinity, that is a divided by 1 minus r. So using all these three formulas, you can easily solve everything that is regarding your geometric progressions.